Hey, Catherine. So the question was, what's up with this x greater than or equal to 2 in terms of why are they restricting the domain of the inverse? And the reason for that is the domain of the original function is the range of the inverse, and the range of the original function is the domain of the inverse. So the same way that the x's and y's swap places, the domains and ranges swap places. So if we look at our original function, which was the root, we know the domain on this, if we had to find it, we'd set 3x minus 2 greater than or equal to 0. We'd bring the 2 over, we would divide by 3, and we'd have the x's have to stay greater than 2/3, greater than or equal to 2/3. And if you look at the red graph here, that's right where this is starting up. So there's our domain of 2/3. So the domain of the original should be the range of the inverse, and if you look at the blue one, which is the inverse, there's that 2/3 again. So the range of the red one, the original, is 2/3 to infinity. The range of the, I think I might have said range, I should have said domain of the red one, 2/3 to infinity. The range of the inverse, the blue one, 2/3 to infinity. So then, if you think of this root and its range, which is easier to see with the graph, but this would just be some root that's been compressed somehow with that 3 and that 2 going on inside and shifted. But the 2 on the outside meant that shifted up 2 units. So the range of the original is going to be from 2 to infinity, or the x is greater than or equal to 2, or y is greater than or equal to 2, in this case because it's range. And so we have to limit the domain of the inverse function to match the limitation of the original function. So that's where they're saying, I didn't do the equals when I typed that, but that's why they're saying the x's are limited to greater than or equal to 2, is because that's the range for the original function. So you kind of have to think about what the original is doing, and then if that has limitations, you have to apply the same limitations when you find the inverse. And that's a little bit, it's really not beyond this course, but they're including that in there to be proper, in that if you just said this is the inverse, this without that, let me just show you, would be this parabola, and that absolutely is not. If you look at the red graph, right, the blue one is not, it has way more going on than the red one did, and we can't have that. They have to have the same domain and range, just reversed of each other. And then that green line that I had there, that was just to show the full line. That's that y equals x, and so they should be symmetrical about that line. So when I have that in there, then you can see if you folded the red and the blue one over the green line, they would totally sit right on top of each other, and they have that symmetry. Hopefully somewhere in there I got that answered, but do holler if you have a follow-up.